Welcome to this video. Students, in this video, I will explain about the source transformation. Source transformation. Before video, I explained about what are the different types of sources we have. Actually, how many types of sources we have? We have two types of sources. Now, what is the meaning of transformation? Transfer. Right. Commonly, our parents will transfer from one place to other place, isn't it? Right? So transformation means what? Which converts the voltage source to the current source or current source to the voltage source. That is the basic concept of this source transformation. Okay? So we have two sources. How many ways we can convert? We can convert into two ways. Those are voltage source to the current source and current source to the voltage source. How it can be converted? How it will changes? Let's see in this video. Okay, students? Now. So, first is the voltage source to the current source. Means what here? You are converting this voltage source to the current source. Next one, current source to the voltage source. IS is converting into the voltage source. Okay? So, what is the universal law? In electrical we use universal law. Which law it is? Yes, it is an Ohm's law. Which law? Ohm's law. What Ohm's law gives us? V is equal to I into R. Basic formula what we have? V is equal to I into R. What is the meaning of V? V is the voltage source. I is nothing but what? A current source. And R is the conductor. R is the conductor. Now, by using this Ohm's law, V is equal to IR or I is equal to V by R. Depending upon these two formulas, we can convert the voltage source to the current source or current source to the voltage source. Okay, students? How? Let's see. Right? Normally, these sources are first one. These are practical sources. Which sources? Practical. When practical source is there, what will be existing? There is a internal resistance will be existing. Internal resistance. Okay? If you observe this circuit diagram, okay, what it is? It is a voltage source in series with the internal resistance across your load resistance. Load resistance. So this is the voltage source. What we are doing? We are converting to the current source. We are converting into the current source. I of S, Ri across the resistance, low resistance RL. Okay? A voltage source is converting into a current source. By using which law? Using Ohm's law. Ohm's law. Dear students, here you have to keep in your mind that always your internal resistance will be constant or same. Whatever the resistance value here, it will be also same here. That you have to keep in your mind to find the internal resistance. Okay, you can convert this voltage source to the current source or current source to voltage, but your internal resistance always it will be same. The value should be same. That you have to keep in your mind. Whenever we are discussing about the voltage source, the internal resistance are in series connection. Which connection? Series connection. Whenever we have practical current source is there, the internal resistance in terms of a parallel connection. Which connection? Parallel connection. Okay, the connections are different, but the values are same. Values are same. That is very, very important in a source transformation. Source transformation. Now, coming to the second part. Second part, what it is? What type of source it is? Yes. What is the symbol of this one? It is a current source. How the internal resistance connected? In parallel across the load resistance. So, you are converting your current source to your voltage source. Voltage source. On which law? Ohm's law. Which law? Ohm's law. Right. So, this is your voltage source in series with the resistance across the load resistance. Why we are doing this source transformation means in a big network. In a big network, if we have some current sources, if we have voltage sources, so to calculate the values are somewhat typical. So what we will do, we may convert the voltage source to the current source or current source to the voltage source, make it into equalizer circuit, equalize sources, so that we can get the value very easily. Right? Suppose all the sources are voltage sources, your internal resistance are connected in series. If all the sources are current sources, your internal resistance are connected in parallel. So these two things are very, very important while doing the problems. Okay? So how many sources we have? How many ways we can convert? What is the basic formula? Basic formula is Ohm's law. Let's do one problem regarding this source transformation. Okay, students? Now, convert voltage to current source. Convert voltage source to current source. When your voltage source is 100 volts and your internal resistance here 20 ohms. 20 ohms. Right. So keep solution here. What is the basic law we have? V is equal to I into R. What he given? He given voltage source how much here? 100 volts. R how much he given? 20 ohms. 20 ohms. What we find here? Current source. What is the formula here? Vs by Ri. Vs how much here? 100. R how much? 20. Then what is the current source here? How much? 5 amps. How much? 5 amps. So how to draw the circuit diagram? What is this? This is your current source 5 amps. How much is the resistance? How much is given? 20 ohms across the load resistance. So this is the way we can convert voltage source to the current source or current source to the voltage source. Now we go for one more problem. Nana. See, convert current source to the voltage source. Convert current to the voltage. What is given? He given a solution. Okay. Current source 25 amps. Internal resistance how much here? 5. What do you find here? Voltage source will be find. Which law? Which law here? Ohm's law. Which law? Ohm's law. So how much I is there? 25. And how much here? 5. Then what is the voltage source here? 125 volts. 125 volts. Okay na? So using this Ohm's law, which we can convert the voltage source to the current source or current source to the voltage source. He may ask question, what are the different types of sources we have and how we are converting the sources. They are very important topic in unit 1. Okay students, so please practice as many as number of problems regarding source transformation. Okay now, thank you.